Okay, guys, let us look at that page, you know. It talks of what? Basically, this topic that we are doing today, and most of the topic we've been doing so far are based on, DC what? Motor. Speed control, that is DC motor calculations. What we did yesterday, motor status, that is motor calculations. Today, we will be doing the one that talks of, a generator. Okay. So, but yeah, before we start, we have to talk of it on it. Compound what? Generator. How do we get a compound? A compound wound generator. It's a combination of a what? Of a shunt winding and a series winding. There are two type of compound generators. That is long and what? Short shunt. Before we start tackling this question, I want us to look each of them individually. Okay, maniqale ngentoni? Nge-long shunt. Okay, compound generator. Okay, so it's a combination of a series and a shunt. So here is my series what? Series field winding. This one. Yeah. Okay. Then it is called long shunt because we are shunting both what? The series field winding and the what? Armature. That is why we call it a long shunt. Shunt means parallel, no? Okay. I want us to analyze what is going on here. No? This is this is my terminal what? Voltage. No? Okay. This is where my armature current. This is what? I series. Series field winding. Then. I what? Series. Here is what? I shunt. Guys, look at the current. In a long shunt, with long shunt, I series is equals to 1. I armature. That making sense? Because I series and I armature, you also I in series. The series field winding and the armature are not in series. Okay. Bang band I load. Okay. For I load, I armature is given by I load plus bani plus I shunt. Look at, I didn't include one I series because I series ulingana no one armature. Remember, this was for a what? A generator. You put a what? A plus because the source current is the armature current. And then OI shunt here, we calculate it as what? V over what? R shunt. Yeah. This is for what? Long shunt. The case won't be the same for Elon short shunt. You look at the circuit, you analyze the circuit. Okay. For I load, you manipulate it up. Okay. Okay. I yes. And I load, they can call it the current delivered by the generator. That is what? I load. Okay, it's delivered to the what? Delivering to the load. Then let us look at it on short shunt. For a short shunt, short shunt. Okay. We have indoni i-field winding ne-series. Sorry, i-series field winding ne-armature, ne? Okay. But the shunt field winding is only shunting what? Only. It is not shunting what? Both of them this time. Hence we say it's a shunt. Okay. Okay. Let us look at our circuit and try to make sense of boya kwenzeka lona. Yena? Nansi current isuka from the armature. You see upper, you can no longer say IA is equals to 1. I series. Because once the current figure upper, I think the split. So here is what? I what? I shunt. Okay. You can, however, say, oh, I load, no, I bunny, I what? As I say, Anna? Okay. And you cannot say I shunt over is equals to V over bunny. I shunt. Because remember now is this parallel winding is no longer connected what? Across. Yeah, but it's connected P up, meaning there is a voltage drop. Does it make sense? No? Yes, if voltage across intoni armature, ne voltage across intoni shunt field windings ziyathini ziyafana, but ayifani intoni terminal voltage. Yabo? No? Okay. So we cannot use this formula. Okay, guys, now you can differentiate between long shunt and short shunt. Okay. In compound generators, there are 3 conditions, that we should look at. Okay. Because remember now we have two what? Windings. And two field what? Windings. That is the shunt field winding and the what? Series field what? Windings. Okay. Okay. I'm just explaining this for calculation purposes. There is a lot of theory behind all of this, of which is I don't want to go into too deep because we don't have time. Okay, we have the shunt field winding, the series field winding. Ana? Sithatha nge-DC, sithatha nge-generators, compound generator. There are 3 conditions which might exist, and I'm gonna read. For example, if field winding of the series can be stronger than of the what? There are 3 possibilities. Or if field winding shunt can be stronger than of the what? Of the series. The third possibility is that they can be the same. That is what we call what? Obtaining what? Level, compounding. When both the series field strength is equal to the shunt field what? Field strength. That we obtain a level compounding. Okay, let me read the statement. Look at part of page 41. Then where it's page this year. Phaya ezantsi ekugqibeleni, ne? Bathetha le nto ndiyithethayo, ne? Okay. If the series field is if the series field is the more dominant field, if the series field is the more dominant field, meaning that the full load terminal voltage is greater than what? The no load terminal voltage. The machine is what? Over what? Compounded. Because kaloku series generator in a high voltage. Yabo? It gives us a high what? Voltage. Yabo? That is why as the load increases with series generator, the terminal voltage what? Increases. That is a characteristic of a series generator. It possesses, now this compound generator possesses a characteristics and what? The series what? Generator. Yabo? ET, meaning the full load terminal voltage is greater than what? The no load terminal voltage. Over what? Compounded. And let us read further. If the shunt field is what? More dominant, meaning the full load terminal voltage is less than the what? The no load terminal voltage. Then that is, the machine is under what? Compounded. Okay. Then if neither field is what? Dominant, meaning they are equal in what? Strength. And the full load terminal voltage is nearly the same as the what? No load terminal voltage. Why would you want O-level compounded? O-level compounded is good for when we want to supply a load that requires a what? Requires a what? A constant what? Voltage. At no load, it must be giving us a 220 volt. At no load. Even at full load, it must be giving us a 200 and what? 20 volts. Okay, because let's say what I was supplying, let's say we are supplying for example, let's say a laptop charge. Izinto esizisebenzisayo zombane, ine-appliances require money. That is the standard voltage in this country. The standard voltage in this country is what? Any electrical product that we buy abroad must operate within 230. Because if we take a hair dryer from America, voltage yabo is approximately on that figure. Yabo. That is what the Americans feel, that it is a safer voltage to use ending than ubani. Our urhulumente feels that 220 is what? Safer for us. Yabo. Okay, so if you take a hair dryer from America and connect it to what? Socket outlet yase South Africa, that hair dryer will what? Burn. Yiloo nto i-adapters kwii-countries zitheni zingafani. Xa unothatha eyase-America i-adapter ufike ayingeni kwi-adapter yaphi, kwi-socket yaphi, yase-South Africa. Yenziwe ngamasibom loo nto because kuyaziwa uba ii-voltage zee-countries are not what? The same. So this is the regulation voltage yase-South Africa. This is what the regulation requires single phase. Okay, in America they have their own sense. Yabo, bona disebenzisa abantu. Okay, so we require ke ngoku intoni i-level compound for that purposes, for our compound generator to give us a constant voltage at no load and what? At full load. That is what level compounding is. A level compound. Okay, let's turn to the next page. It says there, obtaining what? Obtaining this level compounding. How do we obtain it? Okay. In order to obtain level compounding, a shunt generator can be converted into a what? Compound generator. What does this statement means? It says we can take any shunt generator and convert it into a what? Generator. How do we do that? By adding a what? We come here and add a what? A series field winding. Okay, then it in you will be able to determine the number of turns needed per pole. Okay, you will be able to determine the number of turns needed per pole, so that this compound generator that we formed out of the shunt is what? Level compound. Okay, so we need to calculate kumele senze njani these, neither of this field and this field are what? Are dominant. They have the same what? Field what? Strength. Okay. Okay. Silibale i-field strength yekhole ixhomeke kwintoni? Number of turns of the windings, and also ixhomeke kwintoni? Current what? Flowing through the winding. Okay, let's say I want to increase the field strength up. I increase what? The current. I want to increase the field strength. Maybe I can increase the number of turns. Okay, but in this case, in zithini silingane in what? The strength. Okay. Ithi ke ngoku, sometimes you may find that you have, basically, sometimes you can calculate intoni, you can get turns, let's say for me to obtain level compounding ndidinga i-series field coil ena 40 turns. Okay, so ndiyahamba ndiyothini ndiyoyithenga, but sometimes you might find that unayo i-series field coil qha ingubani ine-turns ezingaphi? Let's say 70 turns. I'm making an example. Instead uba uyothenga enye engubani le ifunekayo engubani engu-40 turns, there is another option that you can what? To yabo, decrease intoni? Current. Good. Decrease intoni? Current. Yabo yiloo nto ithi ke ngoku you will find that you have winding already in what? Stock. Yes. Yeah, because there are more what? Turns. That means the field strength is more stronger. So you decrease intoni? Current. How do you decrease the current? You use intoni? A resistance. A resistor. Am I making sense? Okay. Because field strength is directly proportional to number of turns and current flow through your field coil. Okay. Then you may find that you have windings already in what? Stock. So naye uninzi wena uno 70 turns, but ngoba ubala ubone uba udinga i-winding enguba how many turns? 40 turns. Instead uba uyothenga enye, you still have an option. Let's see what is that option. But you may not have the correct what? Number of what? Of turns. This means you will have to change the resistance of the what? Circuit. Because by changing, I will have to change the resistance of the what? Amateur circuit. Yabo? Determine said for not decrease the current PR. By me decreasing the current up, I am basically changing the resistance of the amateur circuit, because the series field winding is always part of the what? amateur circuit. Doesn't matter noma a short shunt or a long shunt, yabo. So if ndifuna reduce the current, I will divert it, and then current flow up the winding is reduced. Yabo. Hence, if field strength can be reduced back to a field strength that is equal to the field strength of the what? Shunt winding. Yeah. So that's how we can do it. So let us look at this example here. Nah? Okay. ET, because once you do one example, this thing is very easy. Very easy. Ninganenzela as well. It's like the one we did yesterday. One example, it only took one example. Ibon. Nale, it's very simple. After I've explained it, yeah, it's straightforward, ngokuba, because you understand what is happening in this calculation. What do we want to accomplish? Okay, it a 60 p out na. So the chapter guys azakhe athetha ngemoto. Talking of a generator here, please. Yama? A 60 a 60 watt a 60 watt, sorry. Shunt what? Shunt generator. Or 60 kilowatts. It's 60 watts, but power solution you see that is kilowatt. So let's write it kilowatt. So error, tapping error pa. Right up work. Right. Has what? Okay, man. 300 volts, it. Okay. Has it turns as ngapi? Okay, the turns. Okay. The turns is the shunt winding. So as a turns, man, 1,800 turns for shunt winding. Anna? Okay. Then they say during what? During no load. The shunt current is what? I shunt is equals to bani 1.8 amps at what? No load. Okay. Anna? Then to maintain, we want to maintain the voltage up until almost the terminal voltage. To maintain the terminal voltage at bani at 300. Want to maintain the voltage at this what? 300 volts. Okay. The shunt field current must be increased to bani. Okay. You might be asking yourself, okay, why is the shunt current doesn't mean? It's because we are converting a what? A shunt generator to a what? A compound generator. You're converting a shunt generator to a compound. Okay. By adding in a series field what? Winding. Why are we converting it to this compound generator? It's because we found that the property a compound generator is advantageous. How is it advantageous? It's because the no load, when it's a compound generator is level compounded, it produces a constant voltage at no load and at what? Full load. Yeah, that is why we do this. Okay, so to maintain that 300 volt, the shunt field current must be raised to 2,4 amps. At what? This is now at what? At full load. Okay. Determine the following. That is what? A. A. The number of series turns per pole to obtain what? Level what? Compound. Okay. The number of series turns per pole to obtain what? Level compounding. When what you do is you calculate a shunt ampere 10 per pole at what? No load. Okay, that is basically I shunt no load. I1 I shunt 1 at no load times intoni a number of what? Turns. Ufumane intoni? Ampere turns the shunt at what? Then the next thing you do, you calculate ampere turns the shunt at what? Per pole at full load. N2. You're sorry, N1 guys, sorry. Okay. Once you got that, this series ampere 10 to obtain a level compounded is basically the difference between what? These two. The shunt ampere 10 at full load minus the shunt ampere 10 at what? No load. Then izosinika ntoni? A series what? Ampere 10 esisidingayo. So a series ampere 10 per pole is basically a shunt ampere 10 per pole at what? At full load minus a shunt ampere 10 at what? And not load. Le nto bayenzileyo phaa babale a shunt ampere 10 at full load and no load. Then they calculated the difference to get intoni? A series what? So into nayo ngoku yintoni? A series what? Ampere 10. Guys, notice that in this question, we are not told whether it's a what? A short shunt. Yeah, because that is also an important statement. When not told, we assume what? See now we can assume what? Long what? Shunt. Long shunt is easier than what? A short shunt. You see guys sends a short shunt. Okay, so we assume long shunt. Okay, we calculated the series ampere 10. Okay, now we need to find intoni? A current because bafuna number of turns. Because remember, a series ampere 10 per pole is basically equals to I bani series times bani N. Okay. So to find N the short hand current because ampere turns the series per pole is bale using the difference between the bani ampere turns per pole of a shunt at full load minus ampere turns of a shunt at what? Low load. And load difference yanika ntoni? It series what? Ampere turns. Okay, meaning which in the shorter end one? The series field what? Current. This of ntoni? A number of what? This of money number of tens. Okay, look at that. They use intoni? power, and the power given is what? Output power, of which is fine for a generator because output power is electrical. So we can say is equals to bani V times bani IL. This is what they did there. They calculated bani or IL. Okay, they calculated what? Or IL. So let us look at that circuit diagram there. You got YA as what? 200 what? Amps. And notice the direction of the what? Of the current. The current is source current is from the what? Amount. Okay. The question long shunt or I series no I money no I amateur are what? Are the same. No? So basically if I calculate I amateur, I calculated I or I money series. But if it was a short shunt, isn't that gonna be a different case? It was gonna be a different case. Yeah. So siqala ngo-short shunt because long shunt is very simple. Okay. And I didn't want a long shunt, but in case it might come, good question paper. Okay, so short shunt. Okay. So guys, if niyabona guys, there are two armature currents. You're sorry, they are what? They are basically how many? They are basically two shunt currents. Okay, let me draw this. Okay, that is a long shunt, no? Okay. Simbali lo I low to bani 200 what? Amps. Sifuna uba le current thina epi ela I bani I series which is equals to I A also. Which the question now that comes into question is that since we have two currents for a shunt, no load, nandoni? No full load. Nazi. Which one should we use? Because xa sifuna u-IA apha sothi bani? IA, which is equals to I load plus bani? I shunt. And your IA is equals to bani? I series, Which current should we use? Let us look at that part that says important. That part that says important. Let us read it. You will notice that the shunt current is what? 4 amps, which was the current during what? Okay. There's a typing error P in the textbook. No load current eating by eating ngu-4 phane. But ka ufunda equation ithi no load current by 1,8. So guys, there's a typing what? Error. So that should be what? They should be saying the no load current was what? Comma bani? Yonke into right. Ukhona la 4 pha eqaleni. So that means it's my textbook that is what? As a typing what? Error. No load current ubani? No load current. Bekufana uba 1.8 kaloku because bathe ngoku si-read question. No load current ubani? Ubhale 1.8. 1.8. So it's my textbook. It's my textbook. My textbook is saying 4. The no load current is 1.8, not 4. Ngabo? Okay. Let us read the further, even further. Now the machine is working at what? Full load. So should we not use the full load shunt current? Why are we using the no load shunt current? Because now the machine is working at what? Full load. Let's see ibizothini impendulo. Ithi no impendulo. Impendulo says no because the shunt field current had to be increased in order to maintain one voltage. No, because the shunt field current has to be increased from 1,8 to what? 2,4 in order to maintain what? A constant voltage. So guys, we use intoni in no load shunt current xa sesiphi la. Okay. So impendulo yethu le. But why are we using a no load shunt current instead of a full load shunt current? Okay, it's because the no load shunt current had to be increased to to this value in order to maintain a what? Constant voltage. So there is no need to change what? The shunt field current because the series ampere turns ensures what? The constant voltage, because there is no need to change this current because now that the machine is a compound, the series field current, because the series field ampere turns is the one that ensures the voltage. Yabo. We increased the current up to ensure the shunt field current up to ensure a constant voltage. But now we don't need to increase it. Yabo. Because series ampere turn are the ones that are ensuring now constant voltage instead of the shunt field current. Sorry, I missed the arrow here. The current, okay, is the one that is ensuring what? The constant voltage. But yet, that shunt field current is the one that it only helps us to calculate in finding the series what? Ampere turns per pole that we will need to maintain this what? Constant voltage. Yeah, was sisebenza only to find what? The series amateur. You also read the series ampere turn per pole. So I didn't want to say amateur. So we use 1,8 the no low voltage. Okay, so OI series then always be OI series is basically I load 200 plus 1,8. Okay, that should be 201,8 what? Amps. Now we have a series field current, we have ampere turn. You can calculate what? The number of what? Of turns. Okay. It round off to what? 6 terms. So basically you round it off to what? 1 decimal. Yeah, ma? You round it off to 1, and it is 5,29 tenths. So round it off a step further if in a comma uthi 6. Okay, because sithetha ngantoni? Sithetha ngee-tens apha ne. Okay, then it beauty, the value of a what? To obtain what? If it goes to le nto besiyidiskhasa le nto, yabo? I-calculation yethu ithi we must have what? 6 what? Tens. But what happens if, let's say, ndisebenzela loo company and ndiyofuna ii-windings esitorum? Bathi estores we don't have i-series field winding ezingubani? Ezinga-6. Thina sine-winding ezine-tens bani? 8 what? Tens. What are you gonna do? Simple. Nancy na. What are you gonna do to maintain i-ampere turns zihlale ziyintoni? Zilaa value le beziyiyo. Andithi zingubani? Cela undibizele. Zingubani? I-series ampere turn per pole zingubani? Series ampere turn per pole leyo ibala nge-difference. Series ampere turn per pole ngu-1080. Ufuna wenze sure uba okay zihlala kule value ku-1080 but ii-turns zakho ngozingaphi? 8. So basically to maintain le value, if lena yanyukile, i-number of turns onyukile, I decrease what? The current. Okay, that is what I'm gonna do. So that series ampere turns are maintained at 1080. Anna? Because at 1080 we are able to maintain money 300 volts. Okay. So how do we find that current? Okay. Because how do we reduce that current? We add in a what? A resistor, but this resistor, we are going to add it in parallel because we don't want to affect the what? Armature current. So basically, we reduce a current flow up by diverting it. Anna? Okay, look at it. If we now use what? 8 turns coil, nah? Then it means that, okay, do you know 1080 equals to bani? I series. Ane? Then it turns on bani? 8. Okay. For it to be maintained at this value, what must be the what? The series field what? Current, which is divide by bani? 8. Divide by 8. That means for us to maintain it at 1080 ampere turns, ne? The series current must be what? 200 and money? 135 what? Amps. The question is, what value of resistance should we use up so that a current flow up ngubani? 135 amps. I-current esuka ku-amateur ngubani? Besibalile ku-200 and bani? 1 comma bani? 8 what? Amps. Andithi bezilingana ekuqaleni. Ane? But ke ngoku azisalingani because sifuna le current ibe ngubani? So that we maintain that series what? Ampere 10 per what? Per pole without having to go and buy i-winding engubani? Ena how many turns? 6 turns. Yabo? Funeka senze elinye iqhinga ngoku. Yabo? Okay. So what do I have? What resistance? What is RD? Yabo? That is basically simple to calculate. Let's go to the next page. If total yam bani ku 200 and bani 201,8. I-current flow apha in bani ID because the current flow apha bani 135. I-current total bani 2 obani 201. Ane? So basically ID i-current ezoflowa kule resistor le ndizoyi-eda apha is equals to bani? IA I what? Series. Uyifumane lo current because izokunceda xa ufuna ntoni? a resistance. Let us continue. If voltage across the resistor, sorry, voltage across the field winding is equals to E voltage across the what? The diverter resistor. Because they are in what? In parallel. So if voltage across the diverter resistor that you added is equals to E voltage across the series field winding. Hence again what city? I D R bani RD, which is the current of the diverter times what? The resistance of the what? Diverter. Ngilena sithini sifunayo. But what resistance can we add in parallel in order to ensure that a current flow up is 135? So is equals to bani voltage across what? The the series field winding. If voltage across the series field winding is I what? Series R bani R series. In terms of what? Ohm's law. Because remember, if voltage drop is given by I times what? R. Okay, thina sifuna bani? U-RD. Basically, u-RD is basically ISRS over I bani? ID. Yeah, that is why we had to calculate bani or ID. Because sizomdinga phi xa sifuna bani? RD. Niyayibona le formula itheni? Ayitshintshi le formula but niyayibona uba itheni? Ivela phi? Okay. Of which is I series man 135. Then ibe yi-resistance series field winding. Then ibe ngubani? Ibe ngu-ID lo mcalculatayo, ne? Then ufumane yonke i-resistance that you would add in parallel to obtain intoni? I-level what? Compound. Yeah. Okay.